Hey guys, Dr. Brown here, and tonight we're working the integral of 1 over x square root 4 plus x squared dx. Okay, so you can see from this one, this looks like a tangent function. So let's let a squared equal 4, and a is the square root of that, obviously, so that's 2. X equals a tangent theta. So the derivative of that, dx, equals a secant squared theta d theta. Okay, so let's fill in the blanks here with what we have. We have dx in the numerator, which would be a secant squared theta d theta, divided by x, which is a tangent theta. Then the square root of 4, which was a squared, plus x squared. So if I square this term, I'll have a squared tangent squared. Okay, you got everything? All right. So those two cancel. Okay, leaving me secant squared theta d theta over tangent theta. I'm going to factor a squared in under the radical here. So I'll have a squared times 1 plus tangent squared theta. Move my d theta out here. Okay, now square root of a squared is a. I'm going to move it to the outside. Then 1 plus tangent squared is secant squared. The square root of secant squared is secant. So now I have secant squared divided by secant, leaving me secant theta over tangent theta d theta. All right, we know secant is 1 over cosine. So I have 1 over cosine theta times, in tangent, 1 over tangent is cotangent, which we know is cosine theta over sine theta. So the cosines cancel. I'm left with 1 over a, the integral of 1 over sine theta. And that's 1 over a times the integral of cosecant theta d theta. Now, if you've integrated secant before, you know there's a trick to making that happen. Cosecant is the same trick. All right, so we have 1 over a, the integral of cosecant theta, and we're going to multiply that by a fraction, and that fraction is cosecant theta plus cotangent theta over cosecant theta plus cotangent theta all to d theta. Now, if we distribute the cosine theta to the inside, we still have our 1 over a, the integral of cosecant squared plus cosecant theta cotangent theta over cosecant theta plus cotangent theta. And all of this is d theta, integrating on theta. Okay, now the u sub time. If I let u equal, I'm just going to put it right here. If u equals cosecant theta plus cotangent theta, du then equals the derivative of cosecant theta is what? Cosecant theta cotangent theta. The derivative of cotangent theta is cosecant squared theta. Well, it's actually minus. I better put that in here. I'm going to forget that negative sign. It's negative cosecant theta cotangent theta minus cosecant squared theta. So that's the derivative of cotangents minus cosecant squared. And then the derivative of cosecant theta equals minus cosecant theta cotangent theta. If I pull that negative to the outside, I end up with that. You'll notice this is the numerator. I have to add a negative sign out here. So this becomes minus du. So I have minus 1 over a, the integral. I should put a d theta out there. So I have the derivative minus the derivative of the function on top of the function. So that gives me minus 1 over a, the natural log of u, but u is cosecant theta plus cotangent theta. Okay, and a was 2, so that's 1/2. Now, we're in the theta world. We started out in the x world, so we need to get back to that. So let's draw our triangle. And that looks terrible. Okay, so we started with x over a was tangent theta. X over a, and a was 2. So this would be 2 squared, which is 4, plus x squared. And the square root of that would be the length of the hypotenuse. So now then, we have minus 1/2 the natural log of cosecant theta. And cosecant is 1 over sine, right? It's the opposite of sine. Sine would be x over square root of 4 plus x squared. Cosecant would be the square root 4 plus x squared over x plus cotangent. Tangent's x over 2. Cotangent would be 2 over x. And plus c. That, my friend, would be the integral of 1 over x square root 4 plus x squared. Now, in the book I looked through, it had a 1 here. I put a 2 there, or 4, just so I could keep the a. I wouldn't get any emails from people saying, well, if that's 1, I don't need the a. Okay. I do that just so you can see the process. If there's some number there besides 1, you need to go through with the a. But I do it even if it's 1, just so I can teach the same process over and over. Okay, hey, let's build a better tomorrow and do that through math. Keep studying. We'll talk to you next time. Thanks.